the post-secondary, so I cannot have them getting a lower mark in here than they would anywhere else, right? That would not be good. Now today is, yes, I just started, yeah. Today is 100% review, okay? Except you're going to hit a different button than all the rest. But in every unit, what have we always finished with? Regression. Bunch of points, stat plot, blah, blah, blah. It's the same thing. And that's why it was so crucial that I had everybody master the first unit, because if you didn't know how to do regression after the first unit, you wouldn't be able to do regression in the second unit, and you wouldn't be able to do regression on the third. And we're going to do regression in one more unit following. So there's 4 units that would have gone bad for you if you didn't learn it the first time. And you can see that's when students give up. They're like, you know what, I just don't get it. Or that's when you can keep them hanging on, because they're like, oh, regression again? It becomes that thing they know so well that there's no anxiety there. It's just like another one of those. Put it in your calculator, get out the formula. Now, what we're going to be doing today is using number 9, which is ln regression. Okay, there is no log regression, it's ln regression, ln. Actually, I'll print it out, right? So we're going to be using that one today. And that's your logarithmic regression. And it gives it to you constant times multiplier ln x. Okay, or y equals a plus b ln x. Now remember that our log curves will either go like this, right, or like this, right? Those are our, right? What do we know about, what's the domain of both of these? X is greater than 0, okay? What's my range? Y is in the reals. What is the x-intercept? Okay, so, you know, that's what the little picture is going to look like. And it's not going to be like, oh, crap, I really understood exponential regression, but this like log regression, it's like, I don't get it at all, right? That would be like a weird conversation. I'd be like, what do you mean? Same picture, same y1, y2, trace, all that stuff. Nothing changes. If we turn to the next page, there's a graph. Hey, look. It looks like a log graph. That is so awesome, because we're doing log regression today. So, right, location of any intercept. Well, look, the x-int is 1. Big surprise. End behavior. Now, this one has a positive, right? So it extends from 4 to 1. Domain, x is greater than 0. Range, y is in the reals. Now, and I just want to kind of talk about, you know how this thing, it goes. It never crosses the x, does it, or the y. And it's because it's got an asymptote there, right? And an asymptote is an imaginary line that it gets closer and closer to, but it never crosses. Okay, is this increasing or decreasing? Increasing. Okay, and then I don't want to answer B, waste of time. Okay, so we're just going to do 2 regression questions. And they want to know location of any x-intercepts, end behavior, domain and range, whether it's increasing or decreasing. Now, the reason why this one looks like 3 different tables, but it's not. It's just the x, and it's just continuing. Okay? So basically, this could have went underneath and kept going. Okay? So it's 5, 165, 12. Like, I'm just wondering, like, do we need to do 2 of these? Let's go to example 3, because you're going to get the point, right? Okay, so we'll just do one of these, and that way you'll have time to finish all your work in class, and then maybe get back some unit tests today, hey? Okay, so let's get this baby out. Now, they're always going to be really nice to us, and the first will always be our x's. And you see, this isn't two different charts. You guys get that, right? It's like a continuation. So, so how do we put that stuff in? Stat, edit. Okay, so 101. So let's just all do it. Since we're only doing one, why don't we all play together? I know some people are like, well, I'll just chill out and watch, but it's good to go through it together. Okay, some big scary numbers, so make sure you don't mess one up. 974,807. This is more of an exercise of not making a mistake than anything. And if I don't make one, it will be a miracle. Okay, so theoretically, I got them in. So even though in the column it doesn't give the number, it changes it to scientific notation, but down below will be the exact one, right? So if it was a diploma, I would definitely just check them quick, because you will get different. You put one of these in wrong, you will get different answers, and then you're frustrated and you're like, oh crap, I don't get these, they don't make sense. Right? Students go there instead of, well, you put a number in wrong. It has nothing to do with getting it or not. Okay, I think I did it right. I highly doubt it, but I think I did it right. Okay, so how do we get my equation? Stat, calc, law and regression, and that's wrong. I must have, because that's not what I got when I did it last time. 101, 91, 81. Did you guys? 61. No? Okay, so there's my one problem. 796, okay. 796,169. 731. Okay, let's try this again. Stat, calc. Okay, I want law and regression. This is so weird. No, the one I have is like totally off from this one. This one, no. This one is, they will never do this to you on the diploma. But this is X and this is Y. Now, oh yeah, no. So, yeah. I know. Yeah, and time's supposed to be X. Okay. So, okay. So, let's pretend this never happened. We will not talk of this. Do not tell your friends. Okay, let's go back to the other one. Because they would never do that to you. Every student in the province would get that wrong if they did their chart that way. Okay? So the page before. If we would have just did this in the first place. You guys are so lazy. Okay. So take 2. All that work. Because that, you're right, that's mean. Time should always be X. Holy, you guys are like burning. It's all that texting you guys do. It's finally coming in handy. See, Austin, you don't have the training you need. Everyone you're competing against in the diploma, they're good texters. You better get on it. It's all one graph. Yeah. Did you get your things in already?
Yeah.
What? Your machine, Yusuf. Oh. Okay. Make sure you're all getting them in, because I don't have the convenience of being able to use my keys like you do. Okay, so go find your linear regression. See if you can get it right. Okay, I'm done. So, StatCalc 9. Come on, work. Come on, baby, we can do this. Yes, that's the right answer. Woo! Okay. So, now, the R squared's pretty high, hey? Now, how do we see this graph? No, before we do that, remember how we see this graph? No. Oh yeah, exactly, yeah, plot 1, let's get it on. Zoom. 9. Okay. So you can see how this is supposed to be like a linear regression. Now how do we put our y equals in there? Vars? You guys realize that's my patented way to do this, right? There's a really long way to do it. Just so you know. Okay. So I want you to just do a rough sketch, or you can just take a screenshot and then you just hit paste and then you just move it down like that. It's easy. Okay, so hopefully we got all this. Y equals negative 6.65 plus 108.49 ln x. Now, the x-intercept, what is it supposed to be? 1, 0, right? That's what it's supposed to. It kind of looks like it might be going through there, but does anyone know how to find that spot right there on a calculator? The y, or the x-intercept, how do you find that? No. Yeah. So go to y2 and make it 0. And your Windows settings, you want to be at below that, right? So your y min is 73 there. We want to make it like, I don't, yeah, negative 20. Okay. So it'll now tell us this because I can use second trace 5, enter, enter, enter. 1.06. Now, why isn't it 1? Because this is all theoretical data. And in real life, right, you're not going to get the exact stuff. But this is because it's, you know, research data, right? What's the end behavior? So it's going from 4 to 1. What's the domain? X is greater than 0. Range, y is in the reals, and the function is increasing. Now, I just want to ask a couple questions and see if we can get the answers. Now, this is, so if x equals, say, 30, find y. Okay, how do I do this? Okay, so to do that, okay, are my window settings big enough? Okay, so we got a window, we want to do x max as maybe 50. So window, I want to make my x max 50. Now how do I find y when x is 30? No. So you have to go trace. No. Trace up. 30. What do we get? So trace, hit the up arrow, and then 30. Oh yeah, I want to get rid of that other one because that's doing some bad stuff. So we do want to clear the other line. Trace. So trace up, and then 30. Okay, so what if we, let's round to the nearest tenth. So the first thing, hopefully you wrote down that we had to go window, we had to go x max is 50 because we do not see that, and we'd get, so since they give us x, we hit trace up 30 and we get 362.3. Okay, now my second one would be what if y is let's go 300. Find x. Okay, so y2, put 300. Okay, is my window big enough for that? Yep. So now I go second, trace, 5, enter, enter, enter. So 16.9. So we have to go y2 equals 300. And then we go intersect. Enter, enter, enter. And we get 16.9. Okay. So we're doing page 187 and 189. 187 to 189. Okay, and if we're working good and quiet, everybody should get done, and we should be able to get our tests back. Okay, so let's not waste this time. You should be able to leave everything behind for the weekend if you get it done.